possibilities?
Yes.
Yes.
Hey, just have your notes. Don't need to tear anything out. Make sure you have your notes out, calculator. Hey.
I wasn't even here.
Yeah.
Oh.
I don't have it.
All right. Okay. All right. Have your notes. Here's what you need to write down. Okay. I would like you right now with your calculator to solve the following problem.
With our calculator, no notes.
No notes.
No, no.
Just notes.
Okay. I want to know the decimal that solves this problem. Put it in paper. You shouldn't need to do too many steps, 1 or 2 steps. I want to see it on a calculator. I want to see it on paper.
I thought you said no
Oh,
paper.
I said paper. Sorry. I said
So
paper.
you want paper?
Paper.
No, you have to put it
Let's
on.
show you the work on the
Can we put it on our
calculator.
notes?
Just do it crossword.
All right.
Mr. Ward, I don't have any paper.
Well, way to come to class on paper. Paper's
Make this bill.
Work here.
I will not be. Ever.
Go.
Jobs. Oh, now.
It expired yesterday.
All right. So, again, I want you to solve this. Fewest amount of steps possible. I want to see it on a calculator eventually. It's just solving an exponential problem. There's different ways to solve it, but I want to see one of your methods to try to write it on paper, try to do it on a calculator. I want to see it in front of you. This is going to be our kind of our opening thing today.
Is this the quiz? This is a 5-pointer.
Oh. Can you see me?
Mar, that pop quiz is hard. You're really gonna.
Oh, man.
It's a brain blender.
It's a brain blender.
Like my brain is like scrambled eggs. They work.
It's like a smooth.
Is that right? Did you just cheat off me?
The camera phone.
Here, look.
You look at her right.
I wrote down paper and I solved it here.
Good.
Beautiful.
Timer.
Oh my gosh.
You like how I wrote every single letter?
Didn't screw up.
Oh my god. I didn't know.
Yeah, we didn't screw up.
Oh, did it?
What?
I know that I did and I was like, oh,
Close.
how did you do it?
Can I just leave it?
Nothing wrong.
He said okay to me.
Wait, there has to do something with
Oh, okay, I see what I did.
Oh, didn't know.
Ward, come here.
That's,
You gotta figure it out.
Yes, come here.
That's right.
They peer pressured me to tell them.
My family.
we did not.
Yeah, he's such a liar.
I felt scared.
He's like,
Did I not check somebody's calculator yet?
Check mine. You didn't check mine.
she's a cheater, don't even bother.
Did I get the right answer?
Yes.
Why, you're right.
Graham, keep going.
Yeah, it's hot in here. Close.
This morning I was like, you did not eat that one.
Not much fun.
You have a class now, it's almost finished.
Yeah. You want Oreo? You want Oreo? And they're muffins, granola bar, or Nutri Oh, I wouldn't.
Okay.
They were already.
Good. Yep. All right. Hey, so for the first one, on the first problem, you have to take the log of both sides if you're going to write it down by hand. Now, this one requires that you have one certain property where you drop the power up front. This is the method that you chose. So you drop the power up front, and then you can divide by the log 3 across. Now, if that's not how you did it, there was another method, right? You divide this over, and you type log 16 divided by log 3. Right? Now, if you didn't, you could have done it with a circle method and did the same thing. Circle method allows you to take this problem and immediately write the answer. It's a lot shorter. You just circle and you equal the power. Log of the base number of 16 equals the x. This is what you type in. This typed in the calculator is that. Because it's a change of base for you.
Is that the exact same amount of
Yes.
steps then?
It's what, 1 step versus 3? If you're actually writing everything else.
Usually you just gotta write that.
Yeah, that. Yeah, that's technically right. That's one step versus writing this out how you
You
get it.
have to, don't you want us to go farther?
So we'll just type it in.
Right, that would take forever.
Okay, all right. Now, that was first one. Second type of problem now. Now we're gonna ramp up the difficulty a little bit.
Ooh.
What? That wasn't the hardest one.
Nope, not even close. Okay, next one.
That's why I don't know the circle method.
Second problem.
Oh, that.
I changed it.
Whoa, we're gonna throw us off.
I'm gonna do this problem and then I'm
Here, come look.
Nah.
I
Oh.
have circles.
Interesting.
Do I need to write anything?
So I don't think I can do the circle method on the
Does that?
calculator.
Mr. Ward, we got the same answer. But I did all the work. I didn't because it's really easy.
Oh, I would definitely have it.
Oh.
Is that gonna get one?
I like to be
Now I get one.
Oh, actually, I should
Okay,
do
so
this
yes,
right now.
Just checking, seeing how you're doing it.
Oh my gosh, plus or minus.
There's two ways to do it again.
Is it a plus or minus?
That is a plus, sorry. That is a plus.
Sorry, I just don't have my glasses on right now. It's
Yeah.
kind of lazy.
You wrote
Good
it,
question, good question. What? Oh, yeah, I got it.
Or, I think I just kind of made something up, honestly.
Mr. Ward, what is the answer?
Correct,
I can tell you that. Not yet.
Mr. Ward, am I on the right track doing it this way?
Come to the seventh row.
It's not.
Oh, I did the seventh now.
I'm doing this.
I know you had to do the seventh too.
Yes.
So what do I do now?
Yeah.
Okay, that's over there, just tap that, and then you still have this over here. So if you solve,
I know I can do that.
I did seven too. Okay, or I was just thinking 7 times 7. You need to leave me alone.
Mr. Ward, that's like I was excelling. This morning you got it.
Not great.
I would be excelling.
we're not done yet.
But I am so far.
We're finished.
They like videos on Snapchat.
I just-
or, like watching Snapchat, and it's just a bunch of I don't want to hate. No, if this is hating, I'm taking it to the
Right.
Fit in there.
Hey, Ward, you like my notes?
I know.
No, it's fun.
It says Ward's way. Do it this way or die.
Yes.
Okay, thanks for listening.
Have a field loss.
Justin, you done?
Zero.
Alright, hey, let's talk about the two methods. Okay, first method, if you want to do it with the power rule. So this is what I mean by power rule. And I think, Sid, I think was the one that I think you were attempting to, but you just wrote down the wrong number. 7 squared is 49, right? 7 squared.
But what's 7 times 7?
7 times 7, I agree.
Okay.
Now, this is 7 squared, and when you have the same bases, they can literally cancel out, and you can set the powers equal to each other, and subtract this 2 over, and you get 0. That's the answer. That's one method. Some people like it. They're like, I didn't even have to touch a calculator. Second method, if you want to do it using the method we just did a little bit ago. The 7x plus 2 equals 49, and taking a log of both sides. Some people do this, some people don't. Because maybe you didn't notice the power rule.
I did that.
So you drop this out front. You drop this out front. The log 49. You would divide the log 7 over. You divide log 7 over, so you get x plus 2 equals log 49 over 7. And then the last step, once you have that log 49 divided by log 7 figured out in the calculator, which is 2, you subtract the 2 over and you still get 0.
I somehow got 1.5. I did the wrong number.
Weird.
I wonder if you did.
I think I did, because I was only off by half, so I must have just put that.
Alright,
So we're doing that Excel class like I do.
alright. Okay, third question. Third question. Okay. Third question.
You.
Okay, here we go. Third one.
And then she'll be like,
Mr. Ward, I think I'm just not meant for this class.
Let's go back to the calculus.
I'm not cut out for calculus. I quit.
like, when we went to the fair, she wanted to try.
Okay.
Alright.
Hey.
What class do you think this is?
Alright. This is the last one of this type that I want to do. After this, we're going to get to story prime.
So, have you ever told a story before? Have you ever told a story before?
Yes.
About what?
I'm looking like this.
Alright, here we go.
Is that the word we turned in or that new one? That's the one that we turned in.
Still the one we were in. Alright.
Something about the E and L, like, is that supposed to
So,
be different?
third one, we'll have story primes after this. I want to see how we're doing here. This one's radically more different than the other ones.
Is radically a hint? Would you get a radical?
No.
So,
Maybe.
I think we do.
I got it.
Okay.
Another way to
Her?
put that.
This one requires that you know your properties really well.
Look at Mr. Ward. Look at my thing. My-
Cover up the power.
How did you figure it out? So
My
I
text
I'm being with the
Wait, no, that doesn't matter.
What are you getting over there?
I have X squared minus 2x plus 1.
If there's logs on both sides, can they cancel out?
Guys, I figured that out. E and LN do.
Can they? No, I know that. Logs, if there's a log on both sides, or it's natural log.
Why aren't they using
Mr. Ward, stop it.
Right? Yeah, they do.
No, it makes sense. Because you told them.
I feel like they do double stuff.
Like the Halloween flavor red.
There's not for Halloween.
Yeah.
I would not buy them if they were.
If they're pumpkin flavored.
One equals, and then be minus one is one. One squared is one. Oh.
Alright.
So natural logs can cancel out if they're on both sides.
Yes.
Awesome.
Oh.
Okay.
So I think we did it wrong.
The property on this one is something that we haven't discussed, and I wanted to see how many people would catch it. I'm betting on not a lot. This is a property we had back in pre-calc. In fact, that picture is directly out of your pre-calc textbook. The property is when you take a natural log and you have an e and a natural log, or natural log and e, that the items cancel each other out, because these are basically inverse relationships with each other. So what you're left with is the item that sits right behind it.
Oh, that's like
So
when you
this
do
is
logs.
just x squared.
Is that like when you're just going
Now, to solve, you would just move everything to one side and solve it like a quadratic.
That's pretty much what it is. It's just super cool. Yeah, I just put the element in there.
Now, it is a quadratic. It can be solved with radicals if you want to complete the square. You can do it. But the idea is that it should be an easy step to set this up, and your answer should be +1.
I feel so healthy when I drink orange juice.
Okay, how I said that, this is the one that I got right, like the first try, and the other two.
Okay, all right. Now, is that the only way? No, obviously not. I'm betting on probably not a lot of people ever attempted it like that structure.
I actually,
You
we
got it right.
You can take the natural log of both sides and drop things out front, and then you can start moving items around. It just takes, it's a process when you do that.
I feel like those smell like meat.
All right. I want you to write this problem down if you haven't already. This is one that we just haven't discussed. These properties are the ones that most people tend to overlook with logarithms. That when they cancel each other out, when they're inverse relationships, it comes down to just knowing your other properties. It's basically these three properties just rehashed. It's just that it's just got a different look to it. And I just think it's important that you actually see those so that they can actually cancel each other out and whatnot. So it's kind of important. So write those down, make sure you have them. But yeah, this answer, by doing it this method, it's a lot faster. I'm betting on a lot of you try to take natural logs both sides, or try to do a circle method and try to move things around.
I did natural log each side.
Okay.
Yeah, it works.
Okay. This is just one of those structures. Those properties on the board are something you need to know. We're going to go through a story problem today, and the story problem itself is going to use these natural logs and natural numbers. And if you have natural logs in them, just remember we have certain properties. Okay, here's the first problem I'd like you to write down.
Okay.
first story problem of the day. It's not really a story problem, it's just more of a grid. But there's an actual storyline to it, if you want to hear it. All right, so what we have here is certain dates, 2005, 2006, 2007, and 2008.
You can't
All right.
just add a category.
Yeah, you really can't do
That does not look good.
All right.
And
So-
and you gotta put down, can you please?
All right. So we have a whole chart, and in this chart is the actual populations. So we're gonna go. These are in thousands.
Can I recommend the next few?
We're not gonna put them all.
I'm ready on that.
All right. So those are in thousands. What I want to know is what are the populations of those times in the middle. So what this problem requires is that we know that it's exponential growth. They say that growth is growing exponentially at a certain rate. Your goal is to find the rate and find the missing values for this problem. Now there's a big long story problem. The census was taken in 2004 with a certain population. In 2008 the population grew to 17.8 thousand people in the city. Find out the missing values for the census when they weren't taken those previous 3 years. So the idea is that this is how you're supposed to set it up. This is the formula we're going to be using. So it's the amount of people total, the initial amount that you're starting with, your growth rate, and your time. Now they didn't say annual growth. We're going past 1 year, so we're going to use exponential
4
growth.
years.
We're actually going 4
We're
years.
actually going
Do it.
6
This is a
years.
rate that we're going to be growing by. The rate is usually the missing number. This is my initial amount, and this is the total amount of people that we have. So this is easy because population does grow in this way, or it can decay in this same process. But you can find it because it's not population doesn't grow linearly. It's not we're adding 50 more people every single year. It grows and it shrinks kind of randomly, so we can get kind of a good average. So.
Wait, why are we using CAD?
I think
What?
that's how-
Never mind, I don't know, I mean.
Okay. So a to the 0. What's my initial population?
15.3.
15.3.
Rate is R, so we don't know any.
Yeah, we don't know the R.
And
The
the T is
time
4.
is 4 years. We're going from 2004 up to 2008. How many people were in 2008?
7.3 billion.
Now,
7.8.
17.8 thousand.
You said how many people
Should we
were
put the
in
zeros in
2008?
there?
That's how many people were alive.
I think it would look cool everyone.
Okay.
Yeah.
Yeah.
All right. So we throw in these numbers. We have to solve. It's the same process we were just doing. What I would recommend on this
Divide by
problem.
15.
Divide this number over first, because you need to get the e with the variable by itself, like single out the variable.
Wait, do we not need this graph or something?
We're going to use the graph. We have to fill in the numbers here in a minute, because we have to go find those times here in a
I'm
second.
just trying to think of where
Yep.
I'm gonna write this all.
All right, so 15.3, we're going to divide that over, e to the 4r, and when we divide 17.8 divided by
Can we just leave it
15.3,
in a fraction so that we can get the.
that's fine. We can leave it as a fraction. We don't need to divide that out and get some weird numbers. But once we're here, we're going to then take the natural log. Why we take the natural log on this particular problem? Because we have an e, a natural number, so you have to take the natural log. If it was just a normal like growth rate of like annual growth rate, like 1.07, where we're not using e, if it's that, then we have to take the log of both sides. But we're taking the natural log here. So this next step is actually taking the natural log of 17.8 divided by 15.3, the natural log on the other side, which is e to the 4r. That way we can drop the power up front using the power rule. Power rule is on the board. It's step number 3. You can see it. And then once you drop that down,
Then you divide by 4.
then you're going to divide by 4, because the natural log of e is actually on this chart as well. The natural log of e is a 1.
CAD is.
Natural log of e is it's whatever the power is on the e, but the e is a 1, or the power is a 1. So this is going to be 4r. We got this natural log of 17.8, 15.3, and on this other side, eventually we have whatever this single number is. Just make sure you're using correct parentheses. And then the last step is divide by 4. I want to know what that growth rate is. It's probably a small percent.
Yeah.
Like,
It's probably at least 9.
I think it's
I just
2.
can't.
can somebody type that in a calculator?
Oh, I got it.
Still brain.
It's like the same.
But you can't
What?
break this
It's
pencil.
0.037.
8.
.037836407.
These don't really stack.
Okay, so about it's almost 4% growth. That's pretty big in population, 4% growth. And now what we can do is we can use that number to now estimate what the years are in the years we didn't take the census.
No, it doesn't roll off.
Will it be accurate? No, but it's going to be really close like that. All right, does everyone understand how we found the R? Is there any questions on how we found R?
No, but now we have to find 2005.
Yeah, we have to find those next dates now. So now we have to know how to go on, because we're not done yet. We found the R. Yeah, we have to plug it in. We have to plug in our initial population, take the R, which my growth rate is 3.78,
And then 1.
and then we have to plug in the years after it. So if we plug in 1 year after our initial population, or 2 years, that's getting to these.
Wait, I have a question. Do we need any more boxes than just like the ones under the ears?
What? No.
No? Okay, good.
Okay, what I'd like you to do is I like this pod to figure out number 1, number 2, number 3-ish.
Number 2?
You got a bunch of, okay.
That's one.
All right.
What do you mean by number 1?
You're figuring out, so those gentlemen are figuring out 2005, you guys will figure out
Oh,
2006.
okay.
You guys are 2007. Jaden's got it. Yeah, so if you haven't typed in, really all you have to do is hit enter and plug that number back in.
Okay.
Might take a while, I better give us a couple minutes.
Okay, now, did my group in the back get the numbers figured out?
What?
You guys get that second 2006 figured out?
We're still doing it.
Okay,
Just wait.
Looking along.
yes, all right, first one, what's the number?
15.8894.
That's good. 889, all right.
No, I'm just
Okay.
doing 15.9.
15.9, population grew.
That is 4096.
Okay, second group.
17.9.
No!
Can't be that big yet.
Oh,
16.501.
16.501.
He was just being dumb. Not dumb.
Did you
were
say 501 or
Mr. Ward, population could have went down and came back up.
Good. I mean, it's gonna fluctuate, but it's gonna be growth. It's
That's what
17.137.
It's predetermined.
Say it.
17.137. Straussy wants to say it, say it.
All right, there you go. The population is growing. Now, obviously, at this rate, it's going to get faster and faster. The more people, the faster it grows. Now, on a calculator, you can just keep bringing these up. Just hit like Shift Enter, and it'll keep bringing up the actual formula. Then you can just replace that number in the parentheses, the power. Now, does everyone understand where the power is coming from? Like the 1 or the 2 that I'm plugging in?
Yeah.
This is how many years after the initial. So it's 1 year, or 2 years after, 3 years. I could go 27 years down the road.
Let's check it.
Now.
You don't want to?
Now.
I'll
All right.
check it, don't worry about it.
Now, I did promise you get time to work on homework. I'm going to give you the rest of the time. Here's your homework today.
Oh,
Right.
wait, we will let you like 10 seconds.
From personal experience, I feel like class goes by faster when you're actually taking it.
Oh,
The past 2 days is really fucking by.
Mr. Ward.
We haven't done anything about
Why
it.
do you say more?
Is that from Preco?
No.
No, we got stuff like this like last week, Thursday, Friday.
Yeah, we transition.
Got it away.
Wednesday.
Oh, the translations? Yeah, keep that. We're going to need to grab it.
Mr. Ward,
We're still graphing.
Mr. Ward, look at my notes. I went from just having this to having this.
What did it do?
Mr. Ward, I made a different I added that. Don't
Hey.
write that.
What did it do?
I made a graphic.
Thursdays.
On Thursday.
Today's Thursday.
Alright, I didn't mean to yell.
Homework, do Thursday.
Can it just be one page?
Yeah.
Do Thursday, page 33.
How about one drop?
2 through 6, even. 7 through 13 odds, so you can check the backs on those.
Are you encouraging
14
that we
through
check the
18
back?
evens.
I don't like the ends.
These are all simple calculations like we did earlier today, like those first 3 or 4 problems we did. 3, I guess. Simple calculations. 26, 27, 32, 35, and 38 through 2. Kind of jumping around. The last ones are story problems. They're basically exactly like the problem I just did. Yep. They're identical to the story problem I have here. You just use exponential growth, you figure out what the rate is, you plug in a new number, you're good to go. It's super quick. If you have a calculator, this goes really fast. The only ones that are going to take time are these first couple, if you have to think about the property that you're using or simplify a little bit, pretty straightforward. There's one problem in particular, I think it's like one of these, where they want you to go from one form to another. So you're like rearranging, you're trying to figure out what E is, that type of thing. I'm going to show you maybe a shortcut for those tomorrow. I might.
Awesome. I'm glad you signed it today.
I know. I might give you a shortcut tomorrow. Question?
Somebody should stop at Dollar General and see if they have any.
Sure, do you want to see a really cool guy?
Anyways, they have goggles or stuff. They have goggles. Yeah, I literally just have they have goggles that have like these little the sun hat. It goes like those are like $3. Oh, those are $3. These goggles are like
So we were typing like.
Hey, we were about to do American for our game tonight, and good thing we didn't because that's like, yeah, what are we? Oh, that would have been awkward. Their motto was be
Oh, my apologies.
it's red, white, and be
Picture of
there.
yes.
It's red, white, and be there. Yeah, it literally like they red, white, and blue. They said red, white, and be there.
What about the blue? Red, blue, or?
No, only red and white. Red, white, and then you show up.
I would
Don't
never
even bring it up. Up again.
No. You gonna play some 2K?
And
Yes.
then type that number in again.
Much more.
Alright, so.
I won't be on tonight. I'll be on. Everything I should do. I'm gonna be on Roger School and TikTok.
I'm not feeling
I
that
will not be at that point.
motivated for what?
I will be on.
Oh, me neither. We have till Monday. We're good.
We haven't do
I really need to. Oh, I was looking at that. It's Thursday. That's ridiculous.
over here.
What day is it today?
I'm not gonna sleep.
Get back. Yeah. So if you don't
Want a little yellow tag.
typing like
All
death.
that.
Do you guys like
I think
this?
it's a back.
Oh, yeah.
Do I like it?
I've been to the years 3. Yeah,
You write the lyrics or what?
I was good.
Try writing your name.
Yeah, you do the X key.
50 times
A
5.04.
lot.
Great
So
city
you have to
marker.
like shift natural one.
Let me go look.
So.
Only Matt works back there now. Let me just check it out.
Okay, but I actually need to write down the
Right. Yeah, my
titles.
back.
Yeah.
Took a picture of my book.
Yeah, you got it.
That's fine.
7, 5.
Bored. I do that every single day.
Let me try it.
Cindy, if you give me a flower, I mean, if you have any of the
So
flower
may I have my water,
names,
please?
if I could have any of the flower names.
7,
Okay.
5, 8.
Sunflower.
Give me
Not
I
Lily.
think my book has lost of these words.
I'm trying to think of other one or two. Tyler. Daisy. Lily is just
They're still
Do we do Ellen?
Daisy.
Yeah,
Daisy's like
great. Violet.
You're
Violet.
overfeeding.
Violet would be fine.
So?
But what I
would be that. We
no, if I could be mustard. Only 12 left.
I felt bad. I was trying to email
Oh,
like
it's
seven.
not
There was
they're
my
purple
friend.
and they're
I went,
like
oh my gosh.
yards, but
Oh, I know exactly what you're talking about. Yeah.
weeds and I'm like,
Yeah. Never
Roger and I
get,
used to
no,
make flowers.
never get
Yeah,
freaked out.
it's not
I have
that
no
with
problem
them.
with you.
Yeah, I would be freaking charged.
No, walk in, you don't swing it all. That's a good thing right there. Do you have an idea? Like, hey, try this. We're going.
I need to like quote that or something. Give me a flower, what would it be? I'd be a weed and be a creeping Charlie.
You gotta add these.
I gotta look up 600
Right.
flowers.
Mr. Ward, did you
I'll
say
find you each of the flowers.
just the phone brain when it goes too much it'll really that just forgets that the brains are just set. Is this real grass? About eat as much
Wait, what the heck is this? Oh, Josh is writing the old pages. Ward. I think so.
Mr. Ward, I give
Cindy, you would be a carnation. Oh my gosh. Carnation. Yes.
I like it.
Petunia. Lucas would be Petunia. Petunia. Begonia.
what?
Hey, can you read the numbers off Marigold?
Do we do it?
We'll fix that. It's
Daffodil?
Mr. Ward, fed it before? Mr. Ward, is this real grass?
Do you want to know what my flower name would be?
Flower,
Ask him what.
yes.
Okay, do you know what mine would be?
I'm gonna go with the lily.
No.
Creeping Charlie.
Oh, definitely, that's a good one. That's really a weed than anything else. That's awesome. Alright, what's mine?
I'm looking for a good one.
Oh, you're just picking at random? I thought you had like a name.
No, we'll think.
You want to be a cactus.
I want a cactus.
Kind of thorny.
You need to leave that. You're thorny? You better post that. You better. I need to